Let's add some more features to our priority queue. Let's make it an adaptable priority queue. And we'll do this by introducing two new concepts, the idea of a decreaser object and a couple of decrease methods, one for the object and one for the priority queue itself. Okay, so we're trying to implement an adaptable priority queue. The idea here is that priorities change. We've already talked about an emergency room example. So imagine that someone's waiting in the emergency room and their condition suddenly worsens. What we'd really like to do is increase their priority so they get faster treatment. And in our case, that's all we're going to focus on, increasing priority of items. Oftentimes, adaptable priority queues also allow priorities to be decreased, but we're not going to worry about that. We'll focus on increased priority. And remember that in our example so far, we've been implementing things like the min heap for a priority queue, where lower numbers represent higher priorities. So that's where the idea of a decreaser and decrease methods come in. They're about making the priority higher, but that corresponds to a lower numeric value for the priority. Okay, we've got a problem with our existing approach. So with our existing approach, if a priority changes after an item's already been added, we don't really have any way of updating it. With something like the heap, the item is somewhere inside the tree or inside the array, if the tree is being stored in an array, and we don't necessarily have direct access to it. And even if we do have direct access to it, we have to figure out how we would actually update the priority and how that would impact the overall tree structure. Right now, we've only really got one way of removing things from our priority queue and no way of changing things that are already in the priority queue. So currently we can extract items, but nothing more. So we need some way to reach into the existing items in the priority queue and somehow update them. And that update process may force the location to change. If you remember when an item's priority basically dictates where it falls in the heap. So we're going to pursue the idea of a concept called a handle. A handle is basically a way of keeping a hold of something, of finding out where something is at. Generically, the concept of a handle is a computing term. It's about having an abstract reference to something. So we need a handle to be able to access a priority. And we'll need some technique, a method. We'll literally use a method in Java that will allow us to update the priority of something that's in our priority queue. So we're going to use an object to represent this concept of a handle. So that's where the notion of a decreaser object comes from. So the idea of a decreaser object is that it is there for us to decrease the numeric value of the priority, which again means that it is more important or a higher priority if the number goes down. So the decreaser is an object that allows us to kind of reach into a data structure and interact with some of the internal details that are stored inside the collection of objects in the data structure. So it's going to need to keep track of some important details. It'll need to keep track of the specific item that we're working with, the thing that represents the concept of priority. It also needs to keep track of its location somehow. And this notion of location is really about two things. It's about its kind of physical location within a particular collection of data, and it's also about which collection it's in. It's pretty easy to have a program that has several different types of collections. So, for example, we could have a program that had multiple types of priority queues, or multiple priority queues. And a decreaser would need details about both where an item is within a particular collection and the specific collection of data that it's in. So we'll look at a more concrete example of how things are organized in a collection for priority queues in just a second. So the decreaser object, in addition to kind of keeping track of what data it represents and where that data is at, it needs some method that we can call in order to indicate we want to increase the priority of an item. So again, decrease its numeric value. So we'll refer to this method as the decrease method. Okay, so I've already described the decreaser objects as somehow keeping track of a location within a data structure. So we'll refer to these as location-aware elements. So the heap decreasers fall in this category of location aware. So they keep track of their location within a particular heap with an index and some sort of information about the specific priority queue, specific heap that they're in. So we're going to be using an array of decreaser objects in the heap. So we'll have to be a little bit careful about swapping items around. So let's look at, so how will we get one of these decreaser objects? How will we access one of these handles? We'll make it a byproduct of inserting something. When we insert something into our heap, we will return a decreaser object that will allow us to get to that item and update its priority in the future. Okay, so the caller can keep this object and use it to request a higher priority. So when we insert something, we'll get back this object that we can use to update the priority of the inserted item. Let's look at an example. Okay, so I'm going to do an example here that's going to represent a heap, and I'm going to keep track of these decreaser objects. So I've already got an array set up that will contain my decreaser objects. And I'm going to establish a notation that I'm going to use for these decreaser objects. So I'm going to assume that our data type is integers, that we're trying to keep integers in increasing order, essentially. We'll represent a heap. So I'm going to do a heap insert of a particular value. My decreasers I'm going to draw with a rectangle. So decreasers objects will look something like this. They'll be divided up into 3 different pieces. So one of the pieces will be the data. Another piece will be their location within the priority queue. So for our array-based priority queue, that location will essentially be an index, so an integer as well. Then also part of this is going to keep track of the specific priority queue they're in. For my purposes today, I'm mostly going to gloss over that last one. Okay, so that's the notation. I'm going to mostly leave the bottom box empty. The topmost box will correspond to an index in the array that we see, and the middle box will correspond to the data that's being stored. Okay. So I'm going to go ahead and start off by doing a priority queue insert. So we'll insert a new node. So let's do I'm just going to abbreviate insert, let's say insert 7. So I'm going to create one of these decreaser objects. It's going to have 7 inside of it. And I'm going to go ahead and connect it up to be the root of my tree. So it's currently in index 1 of my array. So it's going to have index 1 stored as its location element. Okay, the thing that gets returned to an external function is a reference to this object. So all of this stuff, the array and these decreaser objects, they're all kind of going to be handled by our priority queue. But the person who called the priority queue's insert method will be able to directly interact with this decreaser object that we've just created. Okay, if we do another insert, let's go ahead and insert 2. So we'll create another decreaser object. Its data will be 2. We'll go ahead and put it at the first available space in our tree. So that's currently at index 2. Okay, so we've just done the first part of our insert operation. But now we have to do the part that causes the node to move to the top of the tree, which from here on out we'll refer to as the decrease operation. So we would compare this node with its parent. So we would we'd notice that we're at index 2. So since we're at index 2, we can easily identify the parent by dividing by 2. The parent is at index 1. We look at index 1. Index 1 has a value of 7. 2 is better than 7. So what we need to do is we need to somehow update the two locations here. So I'm going to go ahead and do some erasing here, get rid of these pointers. And I'm going to do a swap, and what gets swapped is just literally those pointers. I'm not actually going to do anything significantly different about my objects. I'm just going to swap which one's considered first in our array and which one's considered second in our array. Now the really important thing about that is that anything that has an external reference to one of these items still is connected to the same item. So if I inserted 7 and I have this handle to 7, I still have a handle to 7. If I'd swapped the data, things would have broken. I would have suddenly have a handle to 2 instead of a handle to 7. Okay, so I've swapped these two things, but now I've got an inconsistency. If you remember, the top part of our decreaser objects here represents the index that something is at. And my first item, or this item on the left here, it says that it's at index 1, but in reality it's at index 2. So I also need to update those indices. So I'm going to go ahead and update the indices as well when I do the swap. So the thing with the number 2 in it is now at index 1, and the thing with the number 7 in it is now at index 2. Okay, at this point I've kind of conceptually got a heap where the root item in the heap is the number 2, and its left child is at index 2, and its left child contains the number 7. Let's go ahead and do one more insert operation to get a little bit better sense of what's going on here. So I'm going to insert the number 0. So just like before, I'm going to first have to create my node as the first piece of the insert process. Then I'm going to go ahead and put the data value, the priority, in this new decreaser object. Next, I'm going to deal with the tree's shape property. I'm going to put this in the next available index of the tree, and it's currently an index 3 of our array. And now we're going to go through the process of identifying its parent and deciding whether we need to do a swap. So I'm at index 3. If you remember, to compute the location of a parent, we do the floor of an integer, the floor of a division by 2, or an integer division. So 3 divided by 2 is 1.5, but with integer division it's 1. So that means that my parent is at index 1. So I go to index 1 and access the object from index 1, and I see that it has a priority of 2. So 0 is a lower number than 2, so I need to swap these items. Again, I'm going to use this unusual trick of swapping the references instead of literally swapping the items. So we'll get rid of these two references and we'll just swap them around. So 1 will now, index 1 will now refer to the item we just added, and index 3 will now refer to the item that was there. Okay, again, there's an inconsistency between the indices that are stored in my decreaser objects and where they are in the array. So I need to make sure that those stay consistent when I do these updates. So I'm going to go ahead and erase both of those and update them correctly. So currently the thing at index 3 needs to have a 3 in it, and the thing at index 1 needs to have a 1 in it. Okay, so earlier when I said that these are location aware, it basically means that the objects that we've got, our decreaser objects, have this notion of an index, and the index always keeps track of where it is within the array. Okay, so one more major hint about the assignment. It'll be helpful to you if the priority queue itself has some sort of a decrease method, because you'll need to use this in two different places. If an item's priority changes, it's going to need to move up in the tree. And we've already seen how this works. When we did the process for the insert operation earlier, we looked at a basic while loop that would somehow promote something up the tree. So it suggested that you create a decrease method that will take care of this process. And then you can use that decrease method in two different places. You can use it for this idea of adapting a priority, of increasing an item's priority via the decreaser object. You can also use it from the insert itself. So you'll just consolidate that code in one place.